In this lesson, we're going to be comparing sinusoidal functions. As you can see, this is a sinusoidal function, but it looks a little bit different than the traditional sine wave that we talked about last week. So when I'm looking at this one, or this example, it says, at an amusement park, Miss Goodrow rode 2 different Ferris wheels. She collected data and produced 2 graphs. What can we interpret? So the first thing that I want you to notice is the general shape of these graphs. So the shape of the graphs are both the same. They both start out at their middle points, and the first thing that they do is head up. Okay, so this is good. We don't really need to say anything when we're comparing that. The next thing that we're going to look at is the highest point and the lowest point. So on Ferris wheel A, we have a maximum, and this should change to black here, we have a maximum of 13 meters. So if you look right here, here's our peak, and it is at 13, halfway through between 12 and 14. And we have a minimum of 1. Now when I look at Ferris wheel B, I have a maximum of 7 meters, and it looks like I have a minimum of 1 meter again. Now if we think about what's happening in terms of height and time, so it looks like we get on this Ferris wheel A, and I'm 7 meters above the ground, and I get on Ferris wheel B 4 meters above the ground. The highest point in Ferris wheel A is higher, so obviously Ferris wheel A is taller. I can say that for sure. The lowest point on both Ferris wheels is 1 meter, which means that both Ferris wheels will go approximately 1 meter above the ground. So again, we don't really have to say anything for that one. Now, when I'm looking at Ferris wheel A, I'm in the middle, I hit at the peak, I get back to the middle, I hit the lowest point, and I get back to the middle. Remember, that's called one period or one cycle. Now in Ferris wheel A, that takes 40 seconds. So we have 40 seconds for one cycle. Now Ferris wheel B. So Ferris wheel B starts at the middle, I hit a peak, I hit the bottom, I hit the middle, I hit a peak, and this takes 50 seconds. So really, it takes longer to do one full rotation on Ferris wheel B compared to Ferris wheel A. Now, the last thing that I want to talk to you about is the amplitude. So if we think about a Ferris wheel, I'm going to draw in the top right-hand corner here. I've got a really terrible drawing of a Ferris wheel. Here's me. Oh, I can't draw me. I'll draw me down here in this bucket. We know that the highest point, I'm just going to pick Ferris wheel A for example, is 13, and the lowest point is 1, and so I know that in between here, there's 12 meters. Now that means that this Ferris wheel has a radius of 6 meters, or an amplitude of 6 meters. Now this one was pretty easy to do in our heads, and because I have the graph, it's even easier yet. I could say the middle point is at 7, and so from 7 to 13, that's 6 meters, or from 7 to 1, that's 6 meters. Same thing with Ferris wheel B. My middle is at 4, and it goes up to 7, so that's an amplitude of 3 meters. Or from 4 to 1, again, 3 meters, okay? The very, very last thing that I'm talking to you about right now is something called a sinusoidal axis. It's basically the center. Ferris wheel A, Ferris wheel B. So Ferris wheel A, the center is at 7 meters. We already talked about this, and it's at 4 meters for Ferris wheel B. So here's just kind of a quick summary. When you're comparing functions, you can be talking about the maximum, the minimum, a cycle or how long one rotation takes. We can be talking about our amplitudes, and we can be talking about our sinusoidal axes. The last thing that we're going to do in this note is talk about the speed. So if you've taken physics, and definitely you learned this in grade 9 and in grade 10 science, the speed, velocity, whatever you want to call it, distance time triangle. So what we have here is distance, velocity, maybe you had an S there for speed, and then time. So this triangle helps tell us the formula for all three of these things. If we're trying to find the speed, what this basically tells us is that V, sorry, I don't know what happened there, V is equal to D divided by T. So we're trying to calculate the speed, we know the time that it took, and we need to figure out the distance that this Ferris wheel traveled. So again, I'm going to draw my lovely Ferris wheel here. I know that Ferris wheel A took me, I need to actually flip back and remember, took me 40 seconds to do one full rotation. Add this in here. And Ferris wheel B took me 50 seconds. I don't know how long one full rotation is. I know that the radius is 6 meters, but I don't know how long it actually is to go all the way around. So what I need to do is I need to calculate the circumference. So I'm going to be dealing with strictly Ferris wheel A right now. Now the circumference formula is 2 pi r. So we have 2 times pi times my radius, which was 6 meters. And so if I put that all into my calculator, 2 times 3.14 times 6, I'm going to get 37.7 meters. So that means that if I were to measure how long it was to go all the way around, it would be 37.7 meters. And it took me 40 seconds. So velocity is equal to distance, so 37.7, divided by my time, so 40 seconds, and I'm going to get 0.94 meters per second. Ferris wheel B, circumference is equal to 2 pi r, so 2 times pi times my radius was 3, so 18.8 meters. Next, I'm going to calculate my velocity. So distance, 18.8, divided by time of 50 is 0.47 meters per second. So the last thing that I could say here is that Ferris wheel A is way faster. When I look at it, it's actually twice as fast. So Ferris wheel B is shorter and it's also slower. So I'm going to assume Ferris wheel B is the little itty bitty kitty Ferris wheel.